Okay, thank you, Sir Ray. Okay, can you see my screen, Sir Ray?
Yes, I can see.
Okay,
It's pretty clear.
I think we can start.
Yeah, sure, sure.
Okay, good noon, everyone.
Good noon.
So it's a rainy day. I hope everyone's safe. So my name is Jairus Raymond S. Obrador. So I'm the Applications Engineer Supervisor for Maximum Solutions Corporation. So I am a certified instructor for Autodesk as well as a certified professional for Revit Architecture, Revit MEP Mechanical, Revit MEP Electrical, and Inventor. So I'm here to talk about two solutions that we have in the AEC collection, particularly Dynamo and CAD/MEP. So before I get started with those two, let me just give you a brief recap of BIM or Building Information Modeling. So, so BIM is a process. So this is a 3D intelligent model-based process wherein information is readily available to everyone in the project throughout the whole life cycle of the project. So, uh, as you know, Autodesk is trying to integrate the power of cloud with the BIM solutions that comes in hand. So for this example, we have the AEC collection, and some of the solutions have been already discussed to you by WSI. So they have discussed cloud solutions like the Insight and the Autodesk Rendering and Autodesk Drive. So they have also discussed 3ds Max as well. So I have put here the common phases of building design. So these are the phases of the life cycle. So first we start with the conceptualization, right? So in conceptualization, this is where you create conceptualized 3D models. So they can be intelligent in the conceptualization stage. They can be only geometry, and then this is where you also capture existing conditions through the use of the point cloud technology. So as well as you can perform analysis just like what was discussed by Sir Dennis yesterday using the Insight tool. And you can also start your conceptualization with automations. So using programs like Dynamo and Revit to speed up conceptualization. So I'm not going to go deep into Revit because I know that you have been using Revit for quite some time since you are one of our valued clients. So basically, Revit is the main BIM tool that the AEC collection offers. So pretty much everything revolves around this particular software. And then there's this part where you can automate tasks and optimize design using the Dynamo program within Revit. So this is where you can automate repetitive tasks. You can model complex building systems. And of course, with the help of this, you can improve your design accuracy. So basically, Dynamo is built within Revit. So if you install Revit, you will already have Dynamo as well. So I have some videos here to show you the capabilities of Dynamo. So
Excuse,
um,
excuse me,
here
Dennis.
is
Excuse me
yes.
to interrupt. Can you minimize this small screen? Okay,
Oh,
that's
this
it.
guy.
Yeah, yeah.
Okay.
Okay, thank
Okay.
you, thank you.
Okay. So here in my video, you can see that there's this sample MEP and structural model wherein clashes are detected using Navisworks. And then I'll just skim through the video. So through Dynamo, you're getting the clash results from Navisworks, and then you can create clash indicators within the Revit model so that the clashes can be easily seen. So this video actually was way back in 2018. So there are now changes in the program. I can show you later on the program so that you will have a grasp of what Dynamo is. Okay. So basically, that's what it does, and of course, it will update once that you resolve the clashes. So it will also remove the clash indicators and such. So next here is I call this program the level checker. So basically what it does it is checks the reference level or level of the fittings, MEP fittings and MEP system families. So basically here you will see a set of services laid out, and then through the use of Dynamo, you can actually create a program which actually detects the levels of the services. As you can see here, it's now differently colored. So the red ones for level 0, yellows for level 1, and then cyan is for level 2. So basically here, you can also change the parameters immediately so that the services will be at the same model. I mean, at the same level. So you want to do this so that the reporting of such services in Navisworks and in the scheduling are all in the same level, so it's not that messed up. So I think we can first jump right into our program right here. So can you confirm that you can see my Revit? So basically, if you can now see my Revit screen, we can start by creating, let's say, a blank file. So in this case, I'm creating structural file. So I'll first show you the structural. So basically, Dynamo can be used in all disciplines. So architecture, structure, and MEP. So in this case, I'll be using it in the structural discipline. So just to show you the basics of Dynamo. So you can see your Dynamo in the Manage tab. So for those who have already used this, it's in the Manage tab. And then here I'm going to create a new program. So basically, um, I just want to give you the feel of the Dynamo interface. So basically, the common thing that you do here is to actually type in node commands or nodes in the node search bar. And then once that you select them or enter them, you'll be able to see that particular node in the model space, right? So as you can also see in the 3D representation, you can see a point right there. So actually, that's our first point. So basically, the default values here are all 0. So X, Y, and Z are 0. So I can copy this to create another point. And in this case, I can place sliders, so number sliders in this manner. And then let's say I'll place them along the X. And as you can see, I have a value of 1. So that means that the coordinates of that point is 1, 0, 0. And then I can dynamically change it by moving my number slider, right? So now, as you can see, if I want to create a line between them, so all I have to do is to get the node for line, and there, I have lines. So there are certain nodes that can speed up geometry placement, such as point at parameter. So basically what this does is it creates a number of points within your curve, or in this case, our line. And then here I can type a little bit of code so that I can specify the number of our points. So let's say I'll leave that variable to n. And in this case, I want an integer slider so that I have whole numbers of points. And then I'll put them here. And as you can see, once I create or slide the integer slider, you can see that the points are being updated dynamically. And if I minimize this and go to Revit, you can see that those points are also being created. So those points and those lines are also being created. So what I want to do here is actually, let's say I want to do some translations. Let's say I want to translate the points in a certain amount. So I'll create another number slider, and in this case, I want it to be translated at Z. And as you can see now, I can now dynamically have points along my Z direction. So I can continue on doing this. So in this case, I want the line to be translated, and then I can go along. So what's in your mind can be directly translated to Dynamo as long as you can create the algorithm. So in this case, I'll create another line. So what if I want to connect the points below and the points above? So again, you just have to get the endpoints. So the endpoints are the ones above. And I can also get the starting points, which are these ones. So it's all about connecting the nodes with each other, and then accepting the results of the nodes. So basically here, I can also create diagonal lines. So I can copy this one and then replace the endpoints. Replace the endpoints by that. So I have my starting point. So in this case, I need my start points, and I need my endpoints. So there you go. And then, as I have told you, these geometry will be reflected in Revit. And the good thing about here is it's not just that. You can actually integrate, let's say you want to integrate beams within those lines. So in this case, for this line, for these set of lines or curves, I can actually place certain families. So in this case, the level 1, and then the framing type. So we have to dictate the framing type. So take a look here, because at the framing type, you can see set of families which are loaded in the Revit project that we are doing. So in this case, I have a structural template. That's why it's showing structural beams that are in the project already. So in this case, let's say I'm picking this HSS framing. And then if I go to Revit, you can see that um, those lines are now being populated with the framing. So you can see there. So that's the HSS. So I can go on by creating or placing other structural entities on the other lines, but that might take long. So um, once that I close my Dynamo right here, as you can see in the Revit environment, the lines are gone, but the geometry that has been generated are still there. So I have created a program a while ago. So in this case, what if I want to create my structural, let's say we can call it tracing or brush here in this line, along this line. So I can, again, run a program. So in this case, I can open a program in my desktop. So this program prompts me to select a model element. So in this case, I can select this line. And then as you can see, automatically the truss or the bracing has been generated. So I can do a few tweaks, such as adjusting the height. So as you can see, while I adjust the height also dynamically changes in Revit. And as well as you can change the family. So in this case, I'll be changing it to, let's say, W flange. So in this case, you can see that the geometry or the family has changed as well. So if you have questions, you can type them in the chat box. So I can see them later on after presenting. So I can show you other programs, such as for the architectural discipline. So in the architectural discipline, so Dynamo is pretty much used because of the feature of generative design. So in this scenario, let's say I have a mass, a curved surface right here, curved mass surface. So let's say I want to lay out panels right here. So what I need to do here is to divide the surface into grids. And then once I divided those grids, I can get the points, and those can be adaptive points for my adaptive component. So what I'll do here is, again, I'll go back to Dynamo. And then I can open one of my programs again. So in this case, I'll be opening the panel creator program. So this prompts me to select a face. So in this case, I will select this mass, and then it's gonna prompt me to dictate the number of the grids. So do I want it by 5x5 or 4x4? So let's say 4x4. And then after that, it's gonna run the program. So I'm gonna do run. And then what's going to happen is in Revit, there will be a generated set of adaptive components on that particular surface. So if you plan on changing it, so let's say you don't want it equal in the U and V axis, so you can actually create another code block here. So let's say I want it 4x6. and then I can run it again. And as you can see here, Dynamo is pretty much easy to use due to the nodes. So since it's a visual programming language, so no coding required. So as you can see now, you have 4 by 6 roof panels in this roof curve. Okay, so now what I'll do, so you can actually integrate your Dynamo scripts on generative design as well. So generative design is a new feature of Revit 2021. So basically you have this tab in Revit in Dynamo, so you can export this to generative design. So in this case, I can close down my Dynamo program. As you can see, the geometry is still here. And in this case, what I'll do is I can select all of these roof panels and delete those so that I can show you the capabilities of generative design. So once that you have exported your Dynamo program on generative design, you can just go to your Manage tab, and there's a Create Study ribbon in there, and on which the design is already integrated with the Dynamo program using this generative design platform. So in this case, I can actually make dynamic changes on my design. So let's say I want it to be optimized, and then I have a variable of 1 to 10 in terms of roof panel grids. And then in this case, okay. In this case, what I'll do is I can utilize on maxing out the edges of the roof panels. So in this case, I can dictate the minimum and maximum for my edge panels. So I can say that 4 meters to 5 meters of the edge will be the max, and then I can actually get generation. So let's say I'll just do 4 generations in this example, so that it will do the process quickly. So as you can see, this is the generative design environment where it actually computes it. So it basically uses your processor to do some iterations. So of course, if you have a slower processor, this will be a lot slower. So in this case, I have generated 4 generations. So it's still computing. So while it's computing, you can actually view the design that has been developed. So in this case, the edge max here is 4 meters. Okay. So in this case, I can, since it was the only one generated by my generative design program, so this is 4 by 9. So if I click on Create Revit Elements, it will be created right away in my Revit environment. So you can explore this feature, generative design, using your Dynamo, so that you can create conceptual programs like this. So anyway, I'll show you one last program. So I'll just close this. So I'll show you one last program. So this is this actually extends the capabilities of Dynamo to the design phase, because as you can see here, in the design phase, this is where you do the coordination checks using Navisworks, so that the design will have no clashes. But as you can see here in my diagram, Dynamo can actually extend up to this point. Actually, if you are very good at Dynamo, you can actually use this throughout the whole life cycle of the project. But in this case, I'm going to show you its capability with the Navisworks Manage and Revit. So let's just go back to our Revit. So basically, we have this design. So we are on the structural file, and then we have the MEP model also linked. So if I go to my, so I'll just close my generative design, and then I'll go to my Navisworks. And then here, I'm going to open my coordination. So that's basically the MEP model plus the structural model right there. So basically what I'll do here is I'll run a clash detection test. So MEP versus structural. So I'll run the test. And as you can see, I have 5 clashes here. So this is the MEP services clashing on the structural elements. So what I'll do is I'll go to my report tab right here in the clash detective environment of Navisworks, and I'll filter on the contents of my report. Then I'll write this report in XML. So I'll save this in my desktop. So let's say this is test 1. And then what I'll do next is I'll go to my Windows Explorer, and actually I have an already made Excel file which will be integrated to our Dynamo. So in this case, it's the clash results XML-based Excel file. So let's just wait for it to open. So I guess let's just click it again. All right. So basically it's empty, but in this case I can source out an XML file. So I'll import this test 1 that we just did to list all the clashes here. And then I'll hit save. So once I have saved this, I can go back to my Revit environment. And in Revit, what I'll do is I'll run Dynamo once again. So this is where we actually place indicators to our clashes so that we can easily see them. So in this case, I'll run my program for clash detection. So what I'll do here first is I'm gonna browse that Excel file where we placed our clash results, and then I can also set the family type of our clash indicator. In this case, it's already made here. And then once that I run the program, so that's a code, that's a whole code right there. So once I run the program, as you can see, it can place clash indicators in the Revit model, making it easier to see what is there to fix. So basically that's that. So I can actually view that. So now you can actually create wall voids right here to fix the clashes. And once that you save the model, then rerun the whole program once again. So the clash indicators for those resolved clashes will now disappear. Okay. So again, if you have questions, just type them in the chat box. So I think I can pause and check on the on some of the questions. So I have a question here from Sir Ian. So can we integrate the clash detection using Dynamo into Revit without the use of Navisworks? So I don't think so. So basically, you can run the the initial interference checker of the of Revit with Dynamo. So that will work. That will work for hard clashes only. But since Revit has no capability in terms of clearance tests, so those clearances won't be acknowledged. But I think you can do run interference check in Revit. So we just have to, well, I'm not really sure, but we have to look for the proper nodes that can do that. So the important thing here is the report, where it can map out the location of the clashes. So since Navisworks can map out the XYZ and grid location of the clash, it was easier for Dynamo to lay out those clash indicators that we have. But it is possible that you can only use Revit. But again, if you use Revit, you won't be able to map out the clearances. So it is possible, yes. But again, for me, since you have the Navisworks program, I think you need to leverage on that since it is easier to actually generate reports out of Navisworks. So I hope that answers your question, Sir Ian. So if there are other questions, please do type them in the chat box. Okay. So that's it for Dynamo. So basically, I hope you get the grasp of it using the visual programming environment of Dynamo within Revit. So I'll go next to our detailing. So basically, in detailing, this is where you upgrade your LOD 200 and 300 designs to LOD 400. So what you can use there is one of the programs in the AEC collection, which is CAD-MEP. So CAD-MEP is a DWG file producer, or basically you can say that this is an AutoCAD based program. So with CAD-MEP, you can actually lay out LOD 400 content. Let's say you have a partner fabricator. So the fabricator can actually create ITM files or the LOD 400 files. And then since you have the CAD-MEP software, you can lay out these files that were created by your fabricator in the Revit environment. So there are other fabrication programs such as Fabrication ComDuct and Fabrication ESTMap, but we're not going to discuss those programs. So we're just gonna stick with CAD-MEP since it is the one that's in the AEC collection. So these are the LOD 400 parts. So as you can see, all are segmentized. Everything has hangers. So that's one capability of the fabrication CAD-MEP. So actually, if you just install Revit, you're already gonna have the sample configurations that you can use within your Revit environment. So what is the use of fabrication CAD-MEP in the collection? So I'm gonna show you right now. So basically that's that. Yeah, you can do some modeling capabilities in CAD-MEP. So I'll just go to my Revit once again. Okay, is my Dynamo still open? Yes, so I'm just gonna close this. And since I know that you guys start your modeling, your MEP modeling in Revit, so I prepared a Revit sample right here. So if to those who had tried this, so let's go to a 3D view right there. So let's make it shaded. So to those who have tried this, maybe you have done some things like convert this to fabrication part. So first you have to specify the fabrication configuration. So in this case, I'm going to use the imperial content for supply air. So I'll just place this in the loaded services column. So now I can do design to fabrication using this. So as you can see, it's a straight one, and then I can optimize the lengths so that it will be segmentized into LOD 400 parts. Again, this is based on the default configuration in Revit. But again, the proper workflow here is your fabricator gives you those parts and you're the one laying it out so that it will be seen in the 3D model. So you can also, another good thing here is you can also place hangers in your model. So what is CAD MEP for? So as you can see, everything that we're doing here is pretty much manual. So you have to pretty much convert everything here to fabrication parts. And then there are these inline equipment such as dampers that cannot be converted to fabrication parts. So as you can see here, what it did convert is the two ductwork that were aligned, but it did not convert the fire damper into a fabrication part. So there are limitations here. And one more limitation is that you cannot actually change the specification of the configuration in Revit. So that's where you need CAD MEP. So I'm just gonna undo all the changes that we did. So I'll bring it back to the Revit family state. And so what I'll do here is I can actually select all of this. And then in the add-ins tab, I can actually store this as design line elements. So before I store them to design line elements, I'm going to filter first. I'm not going to include the air terminals. And then I can store the ductwork into a design line element. And then what I'll do next is I'm going to select it again, and I'm going to filter once again so that only the air terminals are selected. And this will be my graphic elements. So once that you have stored design elements, design line elements, and graphic elements, you can now create a file out of it, an RIF file. So in this case, I'll call this a sample Revit export file. So in my desktop. And then once that I have done that, once that I have exported it into an RIF file, I can now go to my fabrication CAD MEP right here. And then I can start a new drawing. So in this drawing, I can run a command to actually import that RIF file. And then here in the process mapping, I can dictate on what fitting ignores will I do. So in this case, I did ignore the fire dampers because I will be mapping them out as this FD flange and FD spigot. So you can map individual items directly here in the process mapping window. And here you can edit the specification into what you want in the configuration. So you can use +2 WG design here, but in this case I'll stick with the -2 WG. And then once that I click OK, you can now see that these ductwork are now placed in our drawing area. So as you can see, the ductwork are segmentized immediately depending on the configuration that we put. So in this case, it's a -2 WG. So that's why it has segmentized into this. And what's good about this is you don't have to put the hangers directly or manually, because those hangers are now in the CAD map model as well. So as you can see, there are now hangers, especially for the round ductwork. And most importantly, the fire dampers are now also replaced by fabrication parts. So that's why you want to use CAD map for your fabrication parts and not just Revit. So in this case, what we want to do now is to, of course, return these parts into Revit, into here. So what I'll do is I can do an export. So in this case, I'll do a export, so save match file for Revit, and I can select all of these. And now I can save a match file. So again, I'll say this is sample.maj in my desktop. So once that's done, I can go back to Revit. So I can toggle the visibility of my ductwork, but in this case, I'm gonna put it above the Revit ductwork. So here in your Insert tab, you can find the Import MEP Fabrication Job. So in this case, I'll be selecting that exported MAG file from CADMap. And then once that's done, so it can load a while if there's a lot of elements. So once that's done, you can see that those segmentized ductwork are now in the Revit environment. So actually underneath that is still the LOD 200 to 300 parts, but yeah, so this does the job. And then while in Revit, so Autodesk has also added some features such as, so let's say I'm selecting all of this. So in my, let's say I'm selecting again all of this. So I'll filter them into just the MEP fabrication parts. And then I can create fabrication reports, such as, let's say I want bill of materials for ductworks. So in this case, you can see the available parameters for display, and the parameters that will be displayed are here. So if I click on print preview right here, you can see that there are data in here regarding the ductwork. So as you can see, I have some straight ductwork, and of course some round ductwork, and then the fittings are here. So as you can see, dimensions and quantities, and as well as mass is also in here. And you can also create worksheets for your parts. So in this case, you can actually customize them. So it's pretty customizable. So the parameters available in the right side and the preview on the left side. So if I click on print preview right here, I will be able to see all the item fittings that are needed to be manufactured. Okay, so it's a part worksheet, so you can see the dimensions, the item number, the materials used, and etc. So pretty much that's why you will need this CAD MEP integration with Revit. So basically for that, for this feature, So it's pretty interoperable between these two programs. So I'll just go back here to my presentation. So now we're done with Dynamo and CADMap. So as you can see here, you can pretty much visualize the scope of the programs discussed, as well as Insight, which was discussed yesterday. Yeah. So I have also talked a little bit about Navisworks and, of course, Revit. So here, I will just show you the contents of the AEC collection. So in this particular workflow, you can see that in the red box, those are the programs that are within the AEC collection. And the others outside are programs that are, of course, not included in the collection. So meaning you will have to purchase them individually. Yeah. So pretty much it. I'll just say that the BIM 360 solutions are also there. So as you can see, BIM 360 design and docs pretty much present in the whole life cycle. And then you have coordinate BIM 360 coordinate for cloud clash detection and build for your building costs, quality assurance sheets, and etc. So you have also other fabrication programs like CamDuck. So in CamDuck, this is actually where you create the ITM files. So pretty much fabricators have this program so that they can author the LOD 400 parts. And then in CamDuck, you can also create nesting sheets for your sheet metals used in the ductwork. And ESTMF for estimation and CFD is the computational fluid dynamics. So just to remind you the contents again of the AEC collection. So again, you are subscribed with this. And then what you can do later on is to explore some of the programs as we have discussed throughout the 3-day period of demonstrating these products. So basically that's it. So I'm now open for questions. So if there are questions, so we have a question here by Meg Placido. Are there ready-made scripts in Dynamo, or do we need to make it from scratch? Okay, good question. So let me just show you Revit once again. So wait, let me just minimize this so it might block our view. So in Revit, you actually have in the Manage tab the Dynamo player. So in the Dynamo player, you can actually see some ready-made programs. Okay, yeah. So there are some ready-made programs here. So basically, you're not starting from scratch. So you can actually use this immediately. So you just have to press play on this to run the program. So there is this update sheets name to uppercase. So I would like to show you this. Let me just open a sample file. So as you can see here in my sample file, the sheet names are not in uppercase. So what if your standards are the sheet names are in uppercase? So basically you can run on Dynamo Player. So if I play this, it's gonna update all the sheets in your model. So basically you're not starting from zero. You already have some programs within the Revit installation. And of course, there is a very large community in the internet of Dynamo users that will help you do your programs if you have questions. And also, you can also ask me if you have questions regarding the your codes. So let's say you're experiencing a program, so I can help you debug some of your codes. And so yeah, it's an open source program and pretty much a lot of users. So please don't be afraid on using it. So we can help each other with that. But yeah, some of the programs, some of the complicated programs, you need to make it from scratch. Okay, that I hope that answers your question. There's another question here. So can we still use DynamoScript in a different Revit version? Actually, yes. Uh, while you install Revit, so let's say I have also Revit 2018 in my machine. So it also has the particular Dynamo version for that particular Revit version. So basically, the Dynamo program is integrated within your Revit so that you can run it on the particular version that you have. Um, the only downside is for versions 2017 below, because I think for 2017 below, the Dynamo add-in is not immediately installed. You have to manually install it on the machine so that you can integrate Dynamo with it. So yeah, so it's okay for 2018 up, but for 2017 below, you have to install that specific Dynamo version for that particular Revit version. So yeah, are there other questions? So while you're thinking of your questions, here is my contact. I have placed my email address right there and my Skype. And then if you have questions or um, questions or inquiries, you can email me, or you can go to these following websites. So these following websites actually have enough content to help you within your workflows and technical problems. So yeah, so Autodesk is pretty much a very huge environment with very many users that can help each other in terms of problems in the programs. So yeah, so are there any more questions? So I can see Dynamo questions, but I don't see CAD MEP questions. So is Dynamo that nice compared to CAD map? So for me, yeah, you're right. Let me. So other questions?
Yeah, as we can see, Dynamo is a special tool so that will automate a lot of tasks, no? So it's a good stuff for the 3D modeler that will make our lives much easier. So if there's any question, one zone?
Yeah, you're right, Surrey. Basically, it is a very good program. So if you have LISP in AutoCAD, you have Dynamo in Revit. So you can utilize this tool to automate your workflows.
Yeah,
So yeah,
yeah.
yeah.
Actually, we already introduced Dynamo before, no? But partly the users where we introduced Dynamo already left one zone. So I think we will encourage now other 3D modelers to use this. It's a part of our subscription, no? Dynamo and public CAD map is part of our AEC collections.
Yes. Please do explore it so that the community will grow. Since the Dynamo community in this Dynamo BIM.org is a very big community wherein you can ask your questions and then immediately people will answer. So very much great community in the Dynamo world. Anyway, so I have a notification here. Is that Mami Loiza? Are you raising your hand?
Good afternoon, everyone. Sorry, actually, I have to attend an important meeting, and yesterday I have to attend Autodesk meeting. That's why. Yeah. Good afternoon, Sorry.
Uh,
Good
Good afternoon.
afternoon, ma'am.
Good afternoon, Miss Eloisa.
So yeah, I think we can end it here if there are no more questions. Again, I've placed my email address, so you can, if you're shy right now, you can ask me questions in my email and in my Skype. So yeah, I think we can end it here. So Ray?
Yes, that's for sure. We will get in touch with you once we have for sure we will do have some lot of inquiries once this tools will be part of the 3D modeler. Okay, so
Okay.
thank you very much, Jerus, Miss Eloisa, Maximum Solution. Thank you for this good webinar.
Yes, thank you, Sorry. So,
Yes,
if the question pop up, just email me
sure
or
we
Sir
will.
Julius.
Sure
Yeah,
we will. Okay, so enjoy our late lunch now. So
yeah.
have a good day. Have a
Okay.
nice weekend.
Uh, Okay.
Bye.
Thank you.
Okay, bye.